This is page number 158. This is the diagram high temperature tandem wall and pilot. First question. Before this question, we need to see this question again. Question. What is POSR tandem valve? It means two POSRVs operating in series. The upstream valve is the safety valve set at the system overpressure protection level. Second, downstream valve is the redundant safety valve RSV. Question. Why is such a tandem valve installed in PWRs? Pressurized water reactor. Answer. The objective is to enforce extra safety. If the upstream valve fails to close, then the system pressure would fall, and at a pressure above that at which nuclear boiling occurs, the downstream valve will close. The possibility of either valve failing to open when called upon to do so is guarded against by having three parallel discharge lines, each fitted with the tandem valve set at sequential opening closing pressures. We can see in the figure 4.31. This is the 4.31. We can see solenoid three-way valve, drain, DCM pilot detector, and SV in the top of the diagram. Yes, safety valve, and RSV redundant safety valve. We can see three valves in parallel condition. If the first valve, DCM pilot detector in bottom, if the valve fails to relieve the pressure, the second valve will operate SV. Otherwise, the third valve also will operate RSV. So we can see the feed line in left side of the diagram and impulse line on solenoid three-way valve in bottom, pressurizer in the center. This is the POSRV, redundant POSRV control. So reading description now. POSRV tandem installation with DCM pilot. Courtesy SEBM. It is French company, I think. Next question. What are the basic constructional features of the main valve in the circuit shown in figure 4.29? 4.29 is this is the picture. Again question. What are the basic constructional features of the main valve in the circuit shown in figure? Answer. The piston of main valve is constructed of stainless steel and sports graphite and elastomer piston seals rings. A weak spring maintains contact between the piston operating rod and the valve disc and holds the disc on the seat at low system pressure. The system lift pressure on the safety valve with zero piston pressure is about 7 bar. The cylinder is fitted with an extensively array of cooling fins and thermal barriers are interposed between the cylinder and the valve body. The bellow is an integral part of the disc assembly and isolates the working fluid from atmosphere. So this is the pilot system for a single valve. Next question. What are the constructional features of pilot valves R1 and R2? Answer. Basically, they are spring-loaded autoclave ball valves in which seats moves under the action of the operating cam. Question. What are the potential discharge duties that the SV of the primary circuit of a PWR has to perform following a primary circuit overpressure incident? Answer. Water followed by steam discharge, water discharge, steam followed by water discharge, hydrogen effects, post-accident pressure relief. Again question, what are the potential discharge duties that the safety valve of a primary circuit of pressurized water reactor has to perform following a primary circuit overpressure incident? Answer, water followed by steam discharge, water discharge, steam followed by water discharge, hydrogen effects, post-accident pressure relief. Question. What is the effect of water followed by steam discharge? Answer. If it is necessary to fit a hydrogen loop seal, then at each first lift of the safety valve position, about 10 liters of cold condensate from the loop seal will be discharged followed by saturated steam. Thus, the complete valve suffers a thermal shock, and at each change of direction of the flow fluid inside the valve, transient mechanical shocks are experienced by each component in the flow path. Developed source development and application of pilot operated safety valve, tandem valve for nuclear power plant. Dr. Array and A. Gemingani et al. Courtesy SEBIM. Question: what is hydrogen effect? If sufficient excess quantities of hydrogen are present in the pressurizer, then the hydrogen may be stratify above the steam under the action of buoyancy force. Thus, the valve may experience a sequence of discharge phases. First, incompressible cold water. Second, high velocity hydrogen. Third, lower velocity steam. Since the internal valve components downstream of the safety valve are initially exposed to the conditions in the reactor coolant drain tank, low pressure, incondensable gas, and water vapor, then the valve as a whole can experience three thermal and mechanical transition during a single lift. Question: how can the problem be overcome? Answer: it requires modification of the pilot director assembly as well as the main valve. Question: what are the modification of pilot directors carried out? Answer: the SEBAM group France replaced their erstwhile pilot director with DCM pilot director. The embodies of the following modification features. 1. The helical spring in the earlier design is replaced by a Belleville diaphragm spring. Second, the pilot piston and its elastomer seal are replaced by flexible metal bellows. 3. R1 and R2 valves are combined in a seat ball tube arrangement. 4. At the bottom of the assembly, a further metal bellows, piston, disc and seat secondary pilot are added to ensure large pilot flow rate for large valves. Question: how does this DCM pilot director operate? Answer: as the system pressure increases, it forces the upper piston up against the Belleville spring, and eventually it overcomes the spring force and allows the tube and ball to move upwards. When the ball reaches the seat, it becomes equivalent to closing R1, the isolation pilot in the erstwhile design, see above. With further increase of pressure, tube separates from the ball, equivalent to opening of R2 of the erstwhile pilot, and the fluid above the piston then escapes to the drain. The lower piston moves downwards and isolates the supply of and drains the fluid above the main valve piston. A further method of operating the lower piston is to actuate three-way solenoid valve. Figure 3.4.32. This is the pilot DCM pilot director. So we can see the in this diagram we can see the adjustable Belleville spring in top of the diagram and metal bellows upper piston. This is metal bellows upper piston. This is metal bellows lower piston. Three-way solenoid valve and drain. And drain 1 is in the left side, drain 2 in right side, and feed is from the left side. We can see the seat and ball and disc and seat. This is the enlarged view of ball and seat and disc and seat. Now the operation. If feed entrance from right side, the spring and ball lift the tube. So from drain 1 the pressure will reduce. Otherwise, if the feed pressure increase furthermore, the three-way solenoid valve operates the disc. So from the disc the drain 2 open, so the pressure will reduce further. This is the DCM pilot director. That's it now. We will see the next question further video. Thank you.